March 1st, 2011, we're kind of recapping lesson 2.1 to 2.3. We're in your blue notebook, page 111. We're going to do example 2. We're going to go into depth in it. So the question says, verify that the diagonals of the parallelogram with vertices P, Q, R, S, I've written the points on the board, bisect each other. So all we have to do technically in this question is bisect. We're going to go a little more in depth. So very first thing, we're going to assume this is scaled. I'll actually put the numbers in just so it helps a little. All right, so it's scaled 1 to 1. Our first point P is at -2 and 1. So here's our first point P. Q is at 3 and 3. Here's our Q. R is at 4, -1. There's our R. And S is at -1, -3. S. So we have our points. Going to create a parallelogram. That's about right. It's a little off, but there's our parallelogram. They want us to verify that the diagonals. So the diagonals are the two lines that go through the middle of the parallelogram. They connect opposite vertices. So let's do them in red here. From Q to S, that's one of the diagonals. The other diagonal goes from R to P. Okay? So we have our two diagonals here, and we need to verify they bisect each other. So by verify, that means I need some kind of numeric representation. I need numbers to prove this. Okay? So, first thing we're going to do is I actually want to find the slopes of these two lines. Okay? Which means you guys need to remember the formula, slope of a line. Sorry, to find the slope of the line when we have 2 points, we use y2 subtract y1 over x2 subtract x1. So when I have 2 points, I can only find the slope of a line. Now, technically I have 4 points and I have 2 lines. So I'm going to be dealing with this slope twice. We're going to name our lines just so we know what we're dealing with for each. Our first one is line PR, let's call it. Public relations. There's line segment PR. So we're going to deal with that one. That'll be in our blue. So I'll write the formula once again underneath. And the points for PR, just so we have an idea, P is at -2 and 1, and R, what is it, -4? 4, -1. 4, -1. Okay? So that's line PR. We'll do our other one in red. Other line is RS, is it? I should scroll up a little. QS, there you go. Other line segment's going to be QS. Q is at 3, 3. And S is at -1, -3. -3. Okay? So we have that. We're going to have to do the exact same thing for both of these line segments. We're going to have to find the slope of a line. Okay? So we have our stuff together. First we'll work with line segment PR. We're going to have to call one of the points, PRR, our first point, and the other one our second. So we'll call P our 1s and R our 2s. So when we go to plug it into the formula, it's pretty easy to see. This is our X1, Y1, X2, Y2. That way it's easy to plug right into this formula. Do the rest in black here. So Y2 is our -1, subtracted by Y1 is just 1. So I have the top part. X2 is 4, subtracted by X1 is -2. We'll put that one in brackets. So we've set that up. Now I just got to carry out bedmass, -2 over 4 plus 2. 6. Equivalent of negative 1 over 3. So the slope of line segment PR is negative 1 over 3. That's our rise and our run. So if we look at PR, let's do this in blue, from P to R, that's a negative slope, and it's relatively flat, moving over more than we're rising, so that makes sense. Negative 1 and 3. Q and S, same idea. We're going to need to give, we'll give Q our 1s and S our 2s, so this is X1, Y1, X2, Y2. And we'll plug them into the formula. Same idea, we'll use block again. So Y2 is negative 3. Subtract Y1 is 3. All above X2 is negative 1. X1 is 3. Carry out bed mass. Negative 6 over negative 4, which is equal to 3 over 2. So again, let's take a look. This says the slope of our other line, QS, is 3 over 2. From S to Q, yep, that's a positive slope line. And it looks like it's rising a little more than it's running. It's rising 3, going over 2. So that looks like. These are logical slopes for both of these. So now I have the slopes. Technically, this verifies that they'll bisect. Anytime a slope is opposite, they're going to bisect at some point. We don't know exactly yet where, but if they were the same, then they'd be parallel lines. So if the slopes are the same, then they will never bisect. Okay? But because both slopes of each of these lines are different, they are going to bisect. So technically, that's verification right there. I'm going to go a little farther. I want to find the equation of both diagonals. I'm going to show you how to do that. I'm going to show you how to solve where they bisect. And then we're going to check using our midpoint formula if they're bisecting at the midpoint. Okay?